The history of the Internet begins with efforts to connect computer networks to enable the sharing of information and resources. In the late 1950s and early 1960s, when computer science was still a very new field, the initial goal was to allow multiple users to share the processing power and resources of a single mainframe computer simultaneously. It soon became clear that this idea would evolve into connecting computers located far apart via a network. The Internet Protocol Suite, commonly known as TCP/IP, which forms the technical basis of the Internet, was developed throughout the late 1960s and 1970s under projects supported by ARPA, an agency of the U.S. Department of Defense. During this period, packet switching work by Donald Davies at the National Physical Laboratory in the United Kingdom and ideas developed by Louis Pouzin on the Cyclades network in France made significant contributions to protocol architecture and network design. Thus, U.S.-based research and pioneering work in Europe created a collaborative environment that mutually reinforced each other. During this period, J.C.R. Licklider, while working first at BBN and then at the head of ARPA's Office of Information Processing Techniques, envisioned a network of interconnected computers worldwide, which he described with his famous intergalactic computer network vision. Licklider's vision reinforced the idea that computers could be more than just calculators. They could be communication tools facilitating interpersonal communication and information sharing. Around the same time, Paul Baran of the RAND Corporation laid the theoretical foundation for packet switching by proposing a distributed communication network design using message blocks and not connected to a central node. In 1969, ARPA decided to create the experimental computer network ARPANET to materialize these ideas. Lawrence Roberts was responsible for program management, while Robert Taylor handled the overall direction. For the communication nodes that would form the network's backbone, they collaborated with Bolt, Beranek, and Newman, where they developed specialized computers called Interface Message Processors, or IMPs. ARPANET used a structure directly inspired by Davies and Baran's packet switching ideas, dividing data into small packets and routing them across the network. The first IMP was established at UCLA in 1969, followed by connections to the Stanford Research Institute, UC Santa Barbara, and the University of Utah. Thus, by the end of the year, the first 4-node ARPANET was completed. The login attempt, sent from UCLA to the Stanford Research Institute on the night of October 29, 1969, which failed due to a system error and only reached the letters LO, is considered the first message sent over the network and is regarded as one of the starting points of the modern Internet. ARPANET quickly transformed into an international research network, initially within the U.S., and later extending to countries such as the United Kingdom and Norway. In the 1970s, research on packet switching-based networks accelerated, and many independent networks began to emerge. During this period, Louis Pouzin and Hubert Zimmermann, as part of the Cyclades project in France, developed a simpler and more efficient approach to Internet working that kept the network internals as simple as possible and left end-to-end reliability to the upper layers. This architecture played a significant role in shaping the end-to-end principle later adopted in the design of the Internet. In the same years, Peter Kirstein and his team demonstrated how the concept of Internet working could be applied in practice by connecting the United Kingdom to ARPANET via University College London, establishing one of the first permanent connections between Europe and the USA. Robert Bob Metcalf at Xerox PARC developed the design and initial applications of Ethernet technology for data transmission in local area networks, which quickly became a de facto standard for enterprise computer networks. These studies clearly highlighted the need for common standards to connect different networks. At this point, Vint Cerf and Bob Kahn, in their 1974 paper, defined the transmission control program, which would allow different packet-switched networks to function as a single logical network. This approach later evolved into 2 layers, forming the basis of the Internet today: the TCP and IP protocols, or the TCP/IP protocol suite. Principles developed in the Cyclades project, such as simple routing within the network and complex error control at the ends, directly influenced the shaping of this design. By the 1980s, TCP/IP was increasingly adopted in research networks. On January 1, 1983, all nodes of ARPANET made a mass transition to TCP/IP, a date considered one of the birthplaces of the modern Internet. In the U.S., the National Science Foundation connected supercomputer centers and university campuses via TCP/IP with the NSFNet backbone network from 1985 onwards. NSFNet later became a fundamental component of the commercial Internet backbone.